Maybe a couple of you are trendy and hip like me and you've heard of this new thing called TikTok. Anyone? Any takers on that one? Yeah? All right. So there's this website, this YouTuber, he goes by Mind the Data, and he did something kind of interesting. And that was he pulled down the number of likes on all kinds of videos that are posted on TikTok. And I think I got the data over here. Let's see, right here. He was kind enough to share it with me. So there's the data. And what I've done is I've pulled off the leading digits. Now, pulling off the leading digits is actually a little bit of a nice mathematical challenge here. How would you write a formula that just gives you the leading digit, the first digit of a number? You can actually do it with logarithms. So let's understand a little bit about logarithms in a different way, in particular log base 10. And I'll get back to this book in just a minute. If you take the log of, say, 7, log of 77, log of 700, log of 7,000, what you're going to start to see is a little bit of a pattern. And that is, this is going to be a number between 0 and 1. This is going to be a number between 1 and 2. Let's actually get those numbers. Log of 7, log of 77, log of 700, and then log of 7,000. Now what I want you to notice is how many digits there are in the number and then something about the logarithms. Can anyone predict a little pattern? If I did log of 70,000, I mean, I have no idea exactly what the number is going to be. I can tell you a little bit about it. I think it's going to be 4 point something. Can you see how I'm getting that? So this number here is 1 less than the number of digits you have. So if you take the logarithm, then this digit kind of tells you how long your number is, how many digits it's got. So that's what I did with our data, is I said, you know what? I need to peel off that leading digit. So here's how I did it. Let's see, let me zoom over here. So I first started by taking the log of these numbers. And then there's a function called integer, which is, all right, just chop off the decimal part. Just look at the integer part. So you take 5.298, oh, that gives you a 5. All right, well, that's nice as far as it goes, but I need to get at that leading digit. So then I took this number and divided it by 10 to the 5th power. And that gave me a single digit number. Well, at least a number with 1 digit to the left of the decimal. And then I did the integer function on that. I said, all right, let's just drop that off. So cool. So these are all the leading digits. Now, do you think there's any pattern in these? These are just literally likes that were pulled off of TikTok. The number of likes that you have. Now, some of these numbers are pretty big. Some of them are a little bit smaller. But would there be any pattern to the leading digits? It seems odd to think that there would be, but there is.
They're the same in decimal form. Numbers.
Well, by the pattern, what I mean is the frequency here. How often you'll get a 1, how often you'll get a 2. And if you scan this just briefly, you'll see that there's more 1s than anything else. 9 is the least frequent, or maybe 8s are also pretty low on that scale as well. And what happened is that there was a guy that worked at General Electric. His name was Frank Benford. And back in the 30s and earlier when he was working for General Electric, they didn't have the nice fancy calculators that you have now. You know what you had to do? You had to look up these values in a table. You wanted the sine of 45. You look up in the table, look down to down, sine of 45, and then look over. Wow, that was a pain. What Benford noticed was that some of the early pages in the book, and this was my dad's when he was in college, this is kind of cool, but some of the early pages in the book were dirtier than the later pages, meaning people were looking up logarithms for numbers that were smaller much more frequently than the larger ones. And eventually, he collected data over years and years and years and rediscovered something that now has his name. It's called Benford's law. And that is the probability that a leading digit is a specific number, a specific digit, follows this, this rule. So the probability that something is a leading digit is going to be the log of 1 plus 1 over x. So, wow, that's kind of strange. Could random data like the number of likes you get in a TikTok follow that pattern? Well, let's find out. So I imported our data into Desmos, of course, and here's Benford's curve. Let me plot a histogram of that data and compare it. What do you think? Is that a pretty good fit? These are just randomly selected likes from TikTok. There's 5,150 of them, and yet this curve predicts pretty well what the frequency of each of these leading digits is going to be. So, kind of cool. And it's based on some nice work with logarithms and Benford's law. So, comments or questions? No? All right. Thanks.